So here's chapter 4 of our statistics class. We don't do a lot with probability here. I just want to give you a simple overview so you get an understanding of how we're going to handle probability and probability distributions moving forward. So what we want to talk about briefly is what is probability? Well, for this, it's just simply a numerical value, and it represents the outcome likelihood. In this case, it's something that's uncertain. So you don't know what's going to happen, and you assign a specific probability to it. As we're going to find out, we're going to be able to assign specific probabilities to outcomes, and in some cases we're not going to be able to do that. We're going to have to look at probabilities over a particular range. Those would be our continuous probabilities, and we'll get to that as we move forward. So for us, probability is always going to be between 0 and 1 inclusive. So you can have a 0% chance of happening, a 100% chance, or 1 of happening, but you can't be less than 0 and you can't give more than 100%. We'll also find that in a particular space, all probabilities must sum to 1 or within a range have values associated to 1. When you have a 0, that means it's impossible of happening. When we have something that's 1, it's an absolute certainty and it represents completeness. Now, we're going to talk a little bit here and there about something called experimentation. Everything we do in statistics will be an experiment. When we have a population, we draw a sample. That's nothing more than an experiment. But just a general sense, what an experiment is, looking at a trial. For example, we're looking at the Olympics, and if we look at someone who's a snowboarder, a trial results in one of several outcomes. So if you're a snowboarder in the Olympics and you make the Olympic Games and you're the ladies half pipe, there's only so many exhaustive things that can happen. You can win a bronze, you can win a silver, you can win a gold medal, 3 medals, or you don't win a medal at all. Those are the outcomes. So as we look at those sets, they're trying to predict their chance. So as we look at that experiment, we don't know the outcome. We know there's a chance they might win something. Some might be greater than others, but we know each one of those outcomes, gold, silver, bronze, or not, should have some probability associated with it. And what we're going to take a look at those outcomes, those 4 scenarios, write them in a space, a sample space, and try to assign a probability to them. We can either do it through history, we can use historical values, or we can use some other means where we try to model it in. And we'll get to that as we move forward. When we talk about these probabilities, we want to make sure that when we encounter events, in this case the event being the experiment, we want to see that it's exhaustive, that all possible values are being included, that it sums to 1 in probability. For example, all 3 medals are not earning a medal, and making sure that the outcomes of the experiment are mutually exclusive. That is, you can't not earn a medal as well as earn a medal. So you can't get a silver and a bronze, you can only get one or the other or none, and also including the gold medal. For example, when we look at these probabilities, we can assign randomly probabilities to those particular things. For example, if we let A be the chance that you earn a medal, there's a 10% chance you win gold, a 20% chance you win bronze, and a 15% chance you win silver. That means there's a 45% chance, discretely, that you'll earn a medal. With that being the case, let B be the probability of not earning a medal. That would be 100%. You have to be exhaustive. There's a 100% chance of something happening, either gold, silver, bronze, or nothing. You take 100%, subtract the 45% from the medal winning, and you're left with probability of no medal. 1 minus 0.45 is 0.55. That is a complementary rule. That complementary rule says if I know the probability of a particular event or a subset of an event, I can subtract that from the total known probability of 100% to get a complement to that value. You'll hear me say this a lot in these lectures called complementary rules. 50% chance of winning, 50% chance of losing, because exhaustively they add to 1. So complementary rules play a big part in what we do, because we'll be assigning complementary rules to things in a discrete sense, as we'll see soon, to qualities. We'll see this a lot as we move all throughout statistics. So that's chapter 4 in a nutshell. We're not doing anything with it in terms of problem sets, just simply covering chapter 4. We're going to move on to chapter 5, where we start looking at valuing probabilities to events.